Hey, all you Algebra 1 students. This is our last online math lesson of the year, so hooray for that. We have just a little over, we have this week and next week, and we're done. So sorry that this is getting out to you a little late, but here we go. So our last math lesson is going to be covering 11.4, how to add and subtract rational expressions. So this is adding and subtracting fractions. Hi, buddy. Okay. You want to say hi to everybody?
I did.
You did? Okay, this is Boaz, everybody. Okay, you want to say hi? You want to say hi one more time?
Hi.
Okay, now say bye.
Bye.
All right, bye. Get out of here.
Hi and bye.
This is Esther. Hi and bye. Get out of here.
All right, guys, come on.
All right, so adding and subtracting fractions. Adding and subtracting fractions that have variables is no different than adding and subtracting any fractions. If I had the fraction 5/3 and I wanted to add it with the fraction 2/3, since they have a common denominator, all I have to do is add together the numerators. You can put them over a common denominator. Oh, and don't worry about the fact that I got paint all over me. That's paint. Sorry, I can't really get it off. It's on there pretty good. So all you got to do is add together the 5 and the 2, and you get 7 divided by 3. So the big idea is if you have a common denominator, you add the tops together, the numerators together. So if you look at these first fractions we have down here, they all have common denominators. If you look at 4 over 3y plus 8 over 3y, the common denominator is 3y. So all I have to do is add the tops together because they have a common denominator. So 4 plus 8 is 12. So I have 12 over 3y, and now I can divide. The 3 divides into the 12, making it 4 over y, your answer. Okay? Same thing here. Subtracting, no different. They have a common denominator. So all I need to do is subtract the one on the right from the one on the left, and they remain over a denominator of x minus 2. So 3x minus 4x is negative x divided by x minus 2. And there you go. You're done. Those x's do not go away because there's not an x inside of this 2 over here. Go to the next one. They have a common denominator. So it's 2a squared minus 4. On the top, we have 2a plus 6a. So 2a plus 6a is 8a over 2a squared minus 4. Now, this can simplify a little further. This down here can factor. A 2 is in common. So what this can become is it can become 2 outside of a squared minus 2. And then we have an 8a on the top. So then this 8 and that 2 goes into 8, making it a 4. So then the final answer is 4a all over a squared minus 2. Next one. They still have a common denominator, but there's a little bit difference that this is now a binomial. So it's 6x minus all of 5x plus 6 divided by 4x. All of that is being subtracted. So it is then 6x minus 5x minus 6 divided by 4x. You got to distribute that negative sign. Okay? So 6x minus 5x is just x. So we have x minus 6 over 4x. Nothing is in common in all of them, so nothing simplifies. That's your answer. We still have a common denominator, so it is 7x plus 6 minus all of 4x minus 5 divided by x plus 2. Distribute the negative sign, and you have 7x plus 6 minus 4x plus 5 all over x plus 2. 7x minus 4x is 3x. 6 plus 5 is 11. Nothing is in common in all of them, so that's your answer. Even though it looks big and scary, they all have a common denominator of b squared plus 3b minus 2. So we have b squared plus 3b minus 2 as the common denominator, and in the numerator we have 5b plus 6b, which is 11b, minus 4 plus 6b minus 6. 11b plus 6b is 18b. Not 18b, 17b. Minus 10. All over b squared plus 3b minus 2. Nothing is in common in 17b minus 10. That is going to be your final answer. All right, down below. Okay, what do we do if their denominators are different? This is kind of the meat and potatoes of the whole thing. What happens if we don't have common denominators? All of the problems we had above, all 6 of those, had common denominators. What do we do if we don't have common denominators? Well, it's the same thing we would always do. If I have, go back. Let's say I had an older version of a fraction. If I had 3 divided by 7 plus 5 divided by 2. 7 and 2 are not a common denominator. What would be the least common denominator between 7 and 2? Well, it'd be 14. So then the idea is what do I have to multiply 7 by to get 14? And you have to multiply the 7 by 2. If you multiply the 7, you also must multiply the top. But what would I multiply 2 to get 14? You'd multiply by 7. And I'd also multiply the top. That's exactly the same thing we're going to do here, but we also have variables. So what is the least common denominator between 3 and 12? Well, because 3 goes into 12, it's 12. So we're going to make the denominator a 12. Also, we're going to make it x squared. We can turn the x into an x squared by multiplying by x. So what do I have to multiply 3x by to get 12x squared? The answer is 4x. If I multiply the bottom by 4x, I must also multiply the top by 4x. So 4x times 7 is 28x. What do I have to do to this one to make it a denominator of 12x squared? It already is, so nothing. You add 9, and then you're done. That's it, because 28x doesn't add with 9. So you're done. That's your answer. So let's look at the next one. Binomial denominators. Binomial denominators. The only way you're going to get these binomial denominators to be a common denominator is to multiply them to each other. It's just like the 7 and the 2. 2 doesn't go into 7, 7 doesn't go into 2. We have to multiply the 2 by 7. So our common denominator is going to be 2 minus x times 3 plus x. So I have to multiply the one that's 2 minus x by 3 plus x, which means I also have to do that to the top, 3 plus x. And I have to multiply the bottom of this by 2 minus x. So I got to also multiply the top by 2 minus x. So what I get is 3 plus x multiplied to 7 minus x minus all of 7 plus x times 2 minus x. And now we got to double distribute and make everything come together. So 3 times 7 is 21. 3 times negative x is negative 3x. X times 7 is 7x. And x times negative x is negative x squared. And then I am subtracting all of 7 times 2 is 14. 7 times negative x is negative 7x. X times 2 is 2x. And x times negative x is negative x squared. This whole thing is then going to be divided by 2 minus x times 3 plus x. We're not multiplying this one out. We're not multiplying out the denominator. So we are subtracting all of this. So this gets subtracted, this gets added, this gets subtracted, that gets added. Okay? So 21 minus 14 is 7. We did that one, we did that one. Negative 3x plus 7x is 4x. 4x minus 2x is 2x plus 7x is 9x. So this and this and this and that all make 9x. And negative x squared plus x squared is 0. So the answer is 7 divided by 9x. We could flip that and write it into standard form. 9x plus 7 divided by 2 minus x times 3 plus x. We don't normally multiply out the denominator. Okay, we generally leave it in factored form if possible, but you simplify the top. So there it is. Try it again. We're going to now do just more practice. What's the common denominator going to be? What's the least common denominator going to be? Well, it's going to be 18x squared. So what do I have to multiply the 6x squared by to get 18x squared? I have to just multiply the 6 by 3, which means I got to also multiply the top by 3. What do I have to multiply this by? X squared, which means I also got to multiply x squared to the top. So 3 times 3x is 9x minus 9x to the third. Now, since everything has an x in it, we can simplify now. I can factor out an x. Actually, everything's got a 9 in it too. So I can take out of the top a 9x, which leaves behind a 1 minus x squared. In the bottom, I can also take out a 9x, which leaves behind a 2x. The 9x divided by 9x goes away, leaving me my answer of 1 over x squared divided by 2x. So it's 1 minus x squared divided by 2x. That's your final answer. And the reason why is because every single one of these has a 9x inside of it. So 9x goes into 9x, leaving behind a 1. 9x goes into 9x to the third, leaving behind an x squared. And 9x goes into 18x, leaving behind a 2x. Your simplified answer. All right, this one. Again, we're going to take this entity and we're going to multiply it to this entity. So our common denominator is going to be 2x plus 3 multiplied to x minus 3. I have to multiply this one by x minus 3. So I have to multiply the top by x minus 3. This one is going to have to be multiplied by 2x plus 3. So I multiply the top by 2x plus 3. So I get x minus 3 times 6x minus 4 minus 4x plus 4 times 2x plus 3. Now we have to double distribute and simplify our top. X times 6x makes 6x squared. X times negative 4 is negative 4x. Negative 3 times 6x is negative 18x. And a negative times a negative is a positive 12. Minus the entirety of 4x times 2x is 8x squared. Since these are all both positive in here, everything's going to become negative. 8x squared minus 4 times 3 is 12x. 4 times 2 is 8x. And 4 times 3 is 12. And every single one of them is negative because this gets distributed to all positives, which make them all negatives. We do not distribute the denominator. combine like terms. 6x squared minus 8x squared is negative 2x squared. Negative 4x minus 18x is negative 22x. Minus another 20x is a negative 42x. And 12 minus 12 is 0. And then we have 2x plus 3 times x minus 3. So yes, there's something in common in the top here. There is a 2x, there's a 2x, and then let's see what that leaves behind. So I can take out a negative 2x. But unless that leaves behind a negative 3, which it doesn't. Let's do it anyways, I'll show you. So it's negative 2x outside of an x plus 42 divided by 2 is 21. 2x plus 3 and x minus 3. But nothing goes bye-bye. Nothing gets canceled. Nothing goes away because they're all different. All of these things are different. So that's your answer. You could have also have left it like this. This could also be your answer, depending on what you want. All right. Simplify complex fractions. All right. This is one of the most difficult aspects of what we're going to do in, well, this semester. This is the last lesson we're doing. So, we have a complex fraction going on, okay? What that means is you have a fraction inside of fractions. So you have a big fraction inside of all these littler fractions. So we need to add together these fractions together. So the common denominator is going to be 15, okay? So the easiest way to do this is to multiply everything by the common denominator of all the denominators. But that does actually get a little complicated to look at. So I'm going to show you the other way, but to multiply everything by the common denominator of all the denominators can sometimes be easier. But regardless, we're going to add these together and then we're going to copy dot flop to multiply them. So 3 and 5 is a common denominator of 15. For that common denominator of 15, I need to multiply this one by a 3, and I need to multiply this one by a 5. So 5 times 2x is 10x, plus 4x times 3 is 12x. Copy dot flip or flop. To divide by a fraction, you take this fraction and you flip it, and you multiply it. 10x plus 12x is 22x. So I have 22x divided by 15 times 1 divided by 2x. This 2 divides into 22, making it an 11. And the x go away. And times 1, the answer is 11 over 15. So that whole nasty mess becomes 11 over 15. The x's actually go away. Look at the next one. Okay. What I mean by multiplying everything by the common denominator of all the denominators. Here's a 4, here's an x. Here's a 4, here's a 2x. The common denominator between these three is 4x. Then I have this 2x plus 1. The common denominator of all of them is 4x times 2x plus 1. Now, what you can do is you can multiply every single term by this common denominator. And what it'll magically do is it'll get rid of the denominator and bring it all together at one time. But you have to be able to recognize the common denominator. And you have to do the common denominator of all the denominators. Because this is a 4x, and this is a 4, and this is a 2x. They're all monomials, a single term. Their common denominator is just 4x. But then you have this binomial, and you have to add or multiply it in. You have to include it also. So the common denominator is this. Then I can multiply it. This 4x gets rid of that 4x, leaving me just 2x plus 1 times 2x plus 5 minus a 3x minus 2 times the 2x plus 1 gets rid of the 2x plus 1. So the only thing left is 4x divided by. The 2 makes this 4 a 2, and the x gets rid of the x. So you have 2 times 4, which is 8, times 2x plus 1. So that 2 gets multiplied to the 4, but it also still gets multiplied by the 2x plus 1. The 4 gets rid of the 4, leaving 6x times 2x plus 1. And now we have to manipulate this. We got to reduce this. But in doing what I did here, you don't have to flip and multiply by the denominator. You don't have to flip the denominator and multiply it. It kind of saves a step. But you have to be able to recognize what the least common denominator is of all the denominators. So 2x times 2x is 4x squared. 2x times 5 is 10x. 1 times 2x is 2x. 1 times 5 is 5, minus 4x times 3x is 12x squared, plus the negative gets distributed to the negative, making it a positive, 4x times 2, which is 8x, divided by. We have to distribute the denominator because we have the addition with the multiplication. So 16x plus 8 plus 12x squared plus 6x. Combine all of our like terms. 4x squared minus 12x squared is negative 8x squared. 10x plus 2x is 12x plus 8 is 20x plus 5. Divided by 12x squared plus 6 and 6 makes 22, x plus 8. Now, if every single one of them was even, you could divide out a 2. But they're not all even. This is a 5, it's odd. So a 2 is not in common in all of them. You could potentially factor these to see if they have a common, but they probably don't. This is your answer. Last question. A certain truck gets 25% better gas mileage when it holds no cargo than when it is fully loaded. Let M be the number of miles per gallon the gasoline truck gets when it is fully loaded. The truck drops off a full load and returns empty. What is the expression for the number of gallons of gasoline the truck uses? So inside of here, it's kind of hard to see. Inside of this truck, it says gas mileage equals M. It says gas mileage equals M. Inside of this truck, it says gas mileage equals 1.25 M. Okay, so one of the trucks gets better gas mileage while the other truck gets worse gas mileage. So we need to set up a fraction and compare these two things together. So I'm sorry, my computer is freezing here. Okay, so a certain truck gets 25% better gas mileage on its, inside of here. Oh man, that's so hard to read. So it says 80-mile trip. 80-mile trip. That was what we were missing, or I was missing. I wasn't seeing it. We have an 80-mile long trip. So let M be the number of gas miles per gallon of gasoline the truck gets when it's fully loaded. The truck drops off the full load and returns empty. What is the expression for the number of gallons of gasoline the truck uses? So you take your mileage, which is miles traveled, okay, divided by the gallons used. So this is your equation for gas mileage. Okay, the equation for gas mileage is the miles that you travel divided by the number of gallons that you use. So we're looking for what is the expression for the number of gallons of gasoline the truck uses. So we're trying to solve for gallons used. So in order to solve for this, we have to multiply this to this side and bring that to this side. So gallons used is going to equal the miles traveled divided by the gas mileage. So the miles that we travel, it's changing brightness in this room, so the computer keeps changing. Miles traveled is the same. On one trip it's 80 and on the second trip it's 80, but the gas mileage is what changes. So to find it out, I'm going to have to add two fractions together. So I'm going to have to take the miles I travel, which is 80, divided by M, and add that to 80 divided by 1.25 M. And here is where our difference of adding together expressions comes into play. So to get a common denominator, I have to multiply. I have to bring both of them into 1.25 M. So I have to multiply that by 1.25. So 1.25 times 80 is 100. That's stupid. I could have done that. Quarter of 80 is 20. So it's 100 M plus 80. And that would be your answer. The gallons used is going to be 100, the gas mileage, plus 80 divided by 1.25 M. And we're done. That would be the expression for the gallons of gas you have to use. Okay, that was kind of a lot, I know. But the main idea is common denominators. Least common denominators. And adding the numerators together. All right. There is one more lesson available to you on Math Excel. It is the 11.4 Adding and Subtracting Rational Expressions. That is already available. This video is going to be up after it is coming up shortly. Obviously, it's going to be up by the time you watch this. The test is also available. The Chapter 11 test is also available. Both the 11.4 assignment and the Chapter 11 test are due Wednesday, May 20th. This is Monday. Today is Monday, the 11th. So it's a week away from this upcoming Wednesday, but it depends on when you're watching this video. So Wednesday, May 20th at 3 p.m. That is the last chance to get your grade changed. The last two assignments that you can do to change your grade is 11.4, Adding and Subtracting Rational Expressions, and the Chapter 11 test. Those are the last opportunities to change your grade for second semester. Thank you all for sticking to the end, for however many of you are still listening to this. And thank you all. I've enjoyed being your teacher this year, and come and say hi to me next year. And hopefully we're back in the normal swing of things. Thank you all and have a great summer.